Okay. Good evening, everyone. Myself, Poojan, and I welcome you everyone on behalf of our user group, K8S User Group Canada. And I hope to see you all around here. We will be having two sessions today. So first, I'll get you through what we do as a community and a little brief about ourselves. And then we have two sessions and we'll start with that. So yeah, thank you very much. And I welcome and hope you enjoyed today's meetup. Starting up, this is a run. This community is run by volunteers. I'm one of them, and I have Ashish and Deb who are doing some accommodations for us outside. And okay, forgot to unmute. Yes. Check. Check. Okay. Yeah. So Yong is basically he started this from Singapore, and this is now we are doing it in Canada, and this is our fifth meetup. And if you want to join or follow us on LinkedIn, we really appreciate if you follow us on LinkedIn and share your feedback and suggestion about it. So we are running on a mission. We try to engage community-enabled learning, and we want to expand the Kubernetes landscape, and we want everyone to get skilled with that. And so basically, we would like to thank our sponsors as well. We are sponsored by CNCF, AWS, PECT as well. We do have a few giveaways as well from the speakers, sponsors, and a few other giveaways as well. So stay tuned for that. And this is our LinkedIn page. I would really appreciate if you scan the QR code and follow us. I'm not sure that side of presentation is on or not, but yeah, this is all we have right now. So we have two topics basically today. First one would be leveraging Akeyless wallet platform for scalable secrets management from Akeyless Securities. So without wasting any further time, I would invite Femi to take the mic up and get ready with their presentation. Over to you.
Thank you, Poojan. All right, let me just share my screen here. No, that's not the right screen.
Okay, good luck.
All right, thank you. So thanks everyone for joining me today. Give me a second while I set presenter mode. I only have about 100 slides to go through, so I'll be very, very fast. So I'm just going to talk about secrets management, and if you're familiar with secrets management, then you'll know what the fundamentals of it are pretty much the same, but our approach is a little bit different. And what I have for you also is a fully functional demo environment that you can go to GitHub and download it and then run it yourself in your Kubernetes environment. So before I get into that, a little bit about myself. I'm a technical account manager with Akeyless. I've been here since late 2021. When I first joined, I can probably spell Kubernetes. That's it. And they pretty much said, look, join us, grow with us, learn, and we'll go from there. So 2 years in, and it's been an interesting journey, positively. So Akeyless, again, this is just a high level for those who don't know. It's not a sales pitch. We're a secrets orchestration platform. Really invested in that. So orchestration of anything, this credential-based use case, whether human to machine or machine to machine, certificates, password management, underpinnings of that is what we call DFC. So before I get into DFC, I had a conversation with one of the bank developer experience folks, and he asked, "What do you guys do?" I said, "Secrets management," and he said, "Oh, just like Hashi." I said, "Yeah, but we're SaaS." He had alarm bells going off because, SaaS platform for secrets. Like, how do you trust a third party that you don't know with your secrets? This is your crown jewels, right? And that's what DFC helps to solve. And so at a high level, it's based on what we call distributed fragments. That's the reason why we call Akeyless, right? Because there is no key. The fragments are distributed in 3 different cloud providers. We have fragments in Azure, one in GCP, one in AWS that we manage on the customer's behalf. And then the customers get their own fragment. And what that allows us to do is have zero knowledge encryption. Right? So when they encrypt their secrets on-prem or in whatever environment the customer has, all the fragments have interacted with, but the fragments are never actually combined together. And because we don't have access to the customer fragment, it means that we can securely store the customer ciphertext in a secure manner. And if they lose the customer fragment, and there's no way to retrieve those secrets. One of the unique things that we are doing is the gateway. So has anybody used Vault before? Vault Secrets Management. So we, again, the concepts are similar, except, with Vault where you have clusters and nodes that you have to manage. We're a SaaS platform, and therefore the way we send our SaaS to customers will through this gateway. This stateless Docker container that you can just throw anywhere. You can deploy as many gateways as you need. It can be on-prem, can be in the cloud, can be in a VPC, and the gateway does one is stateless. So it's very lightweight. And it acceleration and service continuity. So for production workloads, if it's given it's a SaaS environment, if the SaaS platform is not reachable, what happens then? So the gateway has this caching capability that is able to cache secrets that it has access to, such that when there is a disconnection and it goes in a disconnected state, they can still work with secrets and interact with secrets. They just can't create new ones when the gateway is disconnected. The other capability with gateway is automatic migration. We already talked about zero knowledge. Customer fragments go on the gateway. And then dynamic rotation, rotated secrets, and dynamic secrets. So both of those are also supported through a gateway. And finally, log forwarding. So any kind of logs that the customer needs to get, they can get it directly from one of their gateways. So that's pretty much it for the presentation for the most part. I'll walk you through just a very brief demo. The demo environment is up on GitHub, so just take a picture of the QR code. What it includes is an Akeyless gateway. It installs that for you. Akeyless secrets injection for Kubernetes secrets. And does all of the wiring of things. So things like you'll configure DNS, it will set up Nginx, Threat Manager, Let's Encrypt. There's an Okta application or a Akeyless application that loads an Okta for you to use, and a Postgres database and targets already pre-configured. You just have to provide the accounts. You have to register to Okta with just an email. Register to Akeyless with your email. So we just go to signup.akeyless.io and you create an account and you have a vault. That's why we call it Vaultless, because you're not actually managing a vault, you're just using secrets management. So before I get into the actual demo and walk you through the platform, by the way, there's a free version, right? So anybody who signs up with an account, you do get up to 5 clients that you can use, and a limited number of rotated and dynamic objects. So for a small lab, for testing, for learning, it's sufficient. Before I go any further, any questions? You have to ask me questions because I have some prizes to give out. I don't want to take them back. Yeah, go for it.
My name is James. We have a lot of rules for any developers in also we have like a sound shop and everything, but the secret is very much, for example, anybody can say, in order to run it, it needs secrets. But then how to copy still develop.
Yeah, so we can. So that's a great question. So thank you for that. This is a wine bottle from James Bond edition. The question was, they have a lot of repos and secrets is a concern. Don't want to give full secrets. So what we do is, ideally, you want to do dynamic secrets that they can fetch based on Arvada. So based on the user, their role, whatever you want to assign as a subclaim, that's what they get access to. So you can say, I'll give you this dynamic secret. And the dynamic secret itself can also be limited with permissions, right? So you can, let's say there's a database, for example, that they want access to, and they only need read-only access. So they can have a dynamic secret that is read-only permission. So we can restrict it further that way. So that way it removes any incentives for anybody to try to save the secret or store it somewhere, because it's ephemeral. After an hour or whatever time we decide, it expires and they have to go fetch it again, as long as they have the permissions for it. So the question for those who have not heard is, do individuals have to have their own answers? No, you can do it based on groups, right? And we don't create identities ourselves. We use whatever identity provider the customer uses. So for example, that's why I have the Okta app. So if you're using some kind of SAML and you have a group that they're a member of, you can have that group become a subclaim that authorizes that user. As long as he's a member of that group, it authorizes him. And then you can set granular folders and secrets you can assign with permissions like read only or lists or read in list, update, delete, right, etc. Right. It would be base. Yeah, and the claims are really anything that we can read. If it's SAML, there's certain SAML attributes that we can read. If it's AWS, there's AWS specific claims that we can get, as long as we can read the metadata and have access to it. Then you can limit it to only one project or one role, and then assign that way. Two questions. So we encrypt data. We encrypt the data. All you're storing with us is the version key. Not even the key, it's the ciphertext that you're storing with us. So from that standpoint, it's not, data is a very broad term, right? It can mean a lot of different things. For us, we're just working with secrets. The Akeyless skills and the Akeyless stuff actually very good rhyme. the Achilles heel and the Akeyless. I would say, from experience, the people in Chicago, and a lot of people come up to me asking for an air gap solution. So that would not work. So we do have an on-tracking component, the gateway that you deploy anywhere, but it needs to communicate to the SaaS. If it's completely air gap, then it won't work. My largest customer is the world's largest retailer. Can't say the name, but you can guess. And they scale massively. So, from a scalability standpoint, it's my smallest customer is actually Toronto. And they're just a small website. I didn't say what kind of website, but they're just small, and they only have 10 or so databases that they want to protect. And that's the beauty of a SaaS solution, right? You can scale it however you want. Did that answer the question? Oh, for it's we're not creating new keys. It's just it is a novel way to manage existing encryption keys. It's just standard encryption, but we're just managing it.
Dynamic.
I'm afraid I have to go to the demo.
The dynamic key, the dynamic secrets that you are actually giving it the files. Are you going to derive the keys from them? And suppose if I want to select PKI, particular PKI, can I do that?
You can. We are a cert issuer as well, so you can also do PKI internal. So we're not a public cert. Like, for example, we don't do certificate revocation and things like that, but we do provide notifications when certificates expire, and we do integrate with Verify, for example. Sorry, I don't have another mic, but if you speak louder.
So this might so my question is what sets you apart from your competition? LastPass or HashiCorp, what's the difference between them that makes us go for your option compared to the other?
So what customers are saying, what I'm just quoting, is that there's a lot of management involved in HashiCorp. It's the build versus buy approach all over again, right? So it's easier to just buy the solution and have somebody else worry about the management of it, and they just become users, right? And that's what I'm going to show you. Yeah.
I was just wondering, in the case of actually you see the version.
Yeah. Or rotated objects as well as static secrets objects as well. Yeah, sorry. Yeah.
So like from security point, you have it split into 3 different providers, right? But I think that like from a risk management point of view, interruption, is that also multiplying that factor by 3 as well? For example, one provider goes down and now you cannot have access anymore?
That's a great question. Yeah, so the way we've architected it, we need to have 2 cloud providers go down completely globally. So we need to have AWS and Azure completely go down in order for that scenario to happen. But if that does happen, I think the world has bigger problems and it kills.
No, so I just follow up. The reason why I asked is sometimes AWS has some quite famous outages, right? So now that you require 2 to go down, that resolves that issue.
Yeah, exactly. And it's not regional either, right? So it would be like if AWS has a problem with one region, we can always serve the fragments from another region. But all of AWS and all of GCP or all of Azure both need to go down.
How do you manage one? Say, because you said about because you also mentioned that other ones can work as option.
Yeah, so if a yeah, so if a customer has proactive caching enabled and the secrets are being served from that encrypted read-only file system on the gateway, then the fragments are not used. It's so sure. So right. So when the gateway first comes up, when it's set up with proactive caching, you set up RBAC on the gateway with permissions that it has for, all the secrets or some of the secrets, so you can define what it has access to. But when it first comes up, it will download all the secrets that it has access to. And then there's an interval, it fetches new secrets within that interval period to update the cache. But the cache actually is not accessible and it's transparent to the user. So the application, the user, they don't know whether they're accessing the secret from the cache or if they're accessing it from the platform. Sorry, question? Yes.
Do you think that you will for release variables? Do you think with Qvault for release variables?
Qvault even for release. Yeah, so we actually support that. That's one of the things I'm going to talk about is you have teams and businesses with specific requirements, and they need to stay on AWS or Azure Key Vault, etc. So in that scenario, we have a secret object that we call External Secrets Manager, which allows you to mirror what you have in Azure Key Vault or, and I'll actually show you that when we get into it right now. So let me just pivot over to, I'll stop this share. And I will open. By the way, this is the repo here and all the components it installs. It's about 15 minutes. You're up and running with this. So I have to put the mic down. Can't work with one hand. All right, so here I am logged into the console. Oh, it's not shared. Right, thank you. Let's try that again. Okay, so I am logged into the console, and this is what it looks like. Console.akeyless.io. So fun fact, the gateway actually has a console of its own itself. So a lot of times when we talk about console, we're saying, are you logged into the backend console or are you logged into the gateway's console? Anyone want to guess why we have console twice? Once on the gateway, once on the backend. It's the same information. You can't tell the difference other than in the top left-hand corner, it says gateway underneath Akeyless.
Close that cache, because all information is, all keys are available.
Close. It's because of the customer fragment. So if a customer is using a customer fragment, the backend doesn't have access to that secret, so they can't fetch it. So they have to proxy through the gateway, which has that customer fragment on it. And the gateway does the fetching. So because it has the fragment and all the fragments are interacted with, the backend doesn't have access to that on-prem component. And so you get into interesting use cases. So I have this customer in the US that wanted to deploy secrets in China, and they had a hard time figuring out how they're going to manage it. Well, now they can just put a gateway there, put a customer fragment on it, and the only way to get access to those secrets is only to go through that gateway. So I'm logged in. You can see all the secrets objects that we have access to. Let me just move this out of the way. So if I click on new, so all the objects, right? Encryption keys, static secrets, rotated, dynamic, SSH, PKI, external secrets manager. So this is where we support Azure Key Vault and AWS and GCP and Kubernetes secrets. What I will do, instead of just showing you, features and stuff like that, I will actually create a database rotated secret and a dynamic secret. This is the same database that is on this repo. So if you install it, you'll see exactly the same thing. So I have what we call a target. So targets are essentially placeholders, objects for the root credentials. So credentials that we need in order to, these are allocated credentials that we use to create rotated objects and dynamic secrets objects. So I can create targets for a bunch of different databases, cloud providers, Kubernetes, operating systems, custom web applications, etc. The one that I have deployed right now is a PostgreSQL target. So when this database is deployed, it's deployed with a default password. And you can see what the target holds is just the database username, the host name, the password, which I can show you. It's my password. But that's okay, because what I'll do next is I will use that target to create a rotated object that will then rotate itself. And in order to do that, it just goes to secrets and keys, create new rotated secret. It's a Postgres database, so I click on Postgres. Next. I'm showing you the web interface of this, but everything I show you here is available through APIs. It's available through our CLI. And the repo actually does install all of those components for you. So I'm going to call this one with one hand. Postgres hyphen rotate. And I will click on next. This is where I specify the target. I don't have to enter the credentials over again. I just use the target credentials. So I specify the target. I tell it that this is going to be a target rotated object, which means that it's going to rotate its own password. I specify the gateway. In this case, I don't have a gateway in the console, so give me 1 second. So for this scenario, I'm going to go to Gateways console. One second, let me get the access ID that I use for SAML. Then I'm logging in as a user. I go to here, enter my access ID. Sorry, was that a question? Third party, like which, like AWS? Yeah, so for AWS, it's the access key and access key secret. So that's how I connected it for GSport. Yeah, so I was storing in a target, and then in the target, I just rotate it. And that's what you're seeing here as well. Is target that database that its password is my password. Right. So as soon as that target comes up, again, I don't have to do this manually, but I'm showing you this for demo purposes. I'll go to Postgres, call it host rotate, click on next. Here I'm going to specify the target. The rotator type is going to be target. And I'll use this gateway. And here's where I specify the policy. So how often do I want to rotate? Every 90 days? Maybe I want to rotate once a day. All right, so I click on finish. And now I have a rotated object. So I'm going to click on rotate secret now. And I just did on-demand rotation of the root password for that database. And if you go to versions, you see the different versions of the secret that we have. And if I go to version 2, it's the new version of that credential. So there's the username, there's the rotated password. And I can click on rotate as many times as I want. Each time it's just going to rotate and create a new database credential. And this is the same approach we use for cloud providers, for any type of credential. So you just, even what we call a custom rotated object. a custom application. Do rotation for it. We just need that credential that we have, the initial credential that is stored in the target needs to be a privileged account that has permissions to create other accounts, and that's encryption level default, I believe, is AES. That's it. I think it's RSA 2048. I think I'm not 100% sure. But you can use a customer fragment to protect that secret, right? So you can see here I have encrypted by Akeyless DFC. So we have, that's our own fragments that we manage. Zero knowledge encryption is not turned on because I don't have a fragment. But if I go to new encryption key DFC, I can specify the type, right? So you can, there's some AES and RSA keys that we support. For ours, though, I think it's RSA.
So if I create this backup, keep it, or is it all paid?
No, you can share it. You can share it even here from the UI, right? Let me go to.
It's still the key that needs to be shared. So
Yeah, the sharing. You can share the actual secret itself with someone. It doesn't matter whether they're internal or external.
you still have the key. How would the user gets access to the key? Once, let's say they're using an API or something, does the key needs to be shared with another user, or do they get access?
It's a service, right? So if the user needs access, they just need to have the proper RBAC and permissions, and then they can access it from there. Yeah. So once they're authorized, then they can access the credential that they need. So the other thing I'm going to create is dynamic secrets. So now for the same database object, I'm going to go to Postgres, click on next. I will give it a name. I'll call it host dynamic. And again, I'm going to specify the same target. This is where we get granular with permissions, right? So if you need this dynamic secret to have read-only access, your creation statement needs to be limited to what they can do because it's creating an account for them. Right? So I'll leave this blank for now, but if whatever requirements you have, you can custom support any type of permission set. So let's pick the gateway. I'm going to click on finish. So now what I didn't show you is I didn't show you the TTL. Default is 60 minutes. So I click on get dynamic secret, and there's the credential, username, password, expiry. And this is decoupled from the rotation part, right? So we can continue to rotate. It doesn't affect the user's ability to get dynamic secret. It's just if the secret is rotated, the dynamic secret producer is going to get the credential created by that new rotated credential.
What's the
Vault. Editors. Akeyless.
basically I think it's
Not easy to do it. So I don't think it's easy. So from a competitive standpoint, yeah, I mean, how do you do it? I don't know what you call it. but they only do evaluate. They have secret these sequencing services. A lot of stuff on applications. Not so easy. It's, yeah, so the competitive edge is really what the customers are driving towards, right? Which is not happening at all. Really, that's the main thing. You can build it yourself, for sure. But instead of spending your time, resources, and money for managing the vault, easier to just use it. And that's what we're seeing. Yes. Customized, yes. So we call it a custom secret producer. And a custom producer basically allows you to, as long as your application, this is going to be my last few minutes, I think. As long as your application supports, can give us a great webhook URL as well as rotate, we can do all of that with your custom app.
So you say there is no keys and it's all like the customer text, right? Let's say in LastPass, if I'm storing my password, I put my key and I don't share it with anyone else. Here everything is actually managed with that. So users want to actually go ahead and keep their own individual secrets. How would you recommend that they?
So so this is a different product, right? It's Password Manager we're talking about. So Password Manager has a personal folder as well. So in their personal folder, they can keep their own secrets.
So anything here is actually made by someone who has that level of access.
Except for the personal passwords.
Okay, so individual passwords can have secrets.
Correct, yeah. So the users, that's an individual's, he just keeps it in his personal folder and the admin can't see it. Sorry, question. I did not cover RBAC, but very quickly, I know we have to go. So here's a role, I called it K8, right? So this is how RBAC works. So I create a role and then I create an auth method. The auth method is a K8's auth method. The subclaim is a namespace. So I'm basically restricting who can fetch that secret with the namespace. And it can be really anything that Kubernetes supports. You can restrict it by pod, by namespace, by labels, etc. And then when you go through the access path itself, this is where we get very granular with what they can see, right? So anyone or workload that authenticates with Kubernetes has access to the Kubernetes folder, and within the Kubernetes folder can read and list all secrets. And you can get very granular in terms of, okay, well, I want to create another folder and give them create or update or delete. There may be a generic folder that you share across different groups that you don't want them to change, etc. So you can give access to the root folder or even down to the specific secret itself. Any other questions? Anything I didn't answer? Yes. I'm sorry, let me take this question first. I did not cover replication, but yes. So if you can, there's a command you can update and send the detail, or you can. So pretty close. So the gateway can be deployed in high availability. So you can have replica sense, you can have it function with a load balancer. You can deploy gateways. We are virtual HSM. HSM, we have a partnership with Talos. So basically, if you list what Talos that is, they store the customer fragment in their Cypher Trust Manager. So that's it. Actually, I do have one other thing. I know short on time, but very, very quickly. Just wanted to talk to you about where to get help, right? So you can go to our docs.akeyless.io. You can email Akeyless. They'll probably come to me. So just say, hey, I met you at the K8SUG meetup, or Akeyless support .slack.com. So you'll see me there as well. Any other questions? I have one more to give away. No questions? All right, one question over there. So if you're making it available, you just give the path to the secret. Or you can fetch the secret value and give the secret value. But it's saying the secret and we have integrations with different CI/CD pipeline. You know, for example, we support most, if not all, of Akeyless open source OSS plugins, because we have a Vault compatible API on the gateway. So anything that already works with Vault, you just create corresponding API key on Akeyless and point it to that endpoint, the HTTP endpoint. And so that plugin works just as if it's native to Vault, but in the backend we do the translation. Thanks, everyone. Sure.
Thank you.
All right. Okay. Yes.
When we have containers, containers are actually built in by the individual organization. And so they already have the restriction on the firewall. Whenever it's going to the outside world, we have the firewall. So within the applications that we are running, that we are controlling, why do we need to care about the network implementing firewall for those containers?
Yeah, that's a very good question, right? So what you're saying is that these containers are built by the same organization, and at a technical level, we have security. So it all depends on the type of workloads you're running in these clusters, right? So if you look at a Kubernetes cluster, among applications that you run, there are also other components of the cluster itself that are deployed as pods in the cluster. So typically, if you don't have security control, in theory, these pods can talk to your application workloads. Also, in custom environments, the type of pods differ. Some pods may process personally identifiable information. And at times, you may have workloads that should be PCI compliant. And in such instances, those workloads have to be cordoned off, segmented from other workloads in the cluster, right? The idea is to ensure that from a network communication standpoint, you adhere to the principles of least privilege, whereby you only grant the required permissions for a given pod to communicate to the pods or services it's supposed to communicate to without keeping it, open, so to speak, right? The idea is if a pod is compromised, you want to limit the blast radius, right? So microsegmentation in any security framework, it's one of the core tenets of any framework, data framework like NIST, PCI, HIPAA. You have to segment your workloads, without which, from a network standpoint, every workload in theory can talk to every other workload. Okay, so from a security framework standpoint, as organizations, when you want to become compliant, you typically, as inputs, consider the regulatory requirements as well as a certain security framework, and the majority of security framework, microsegmentation, is a core tenet. With Kubernetes, what we're seeing in the industry is, regulators and the security folks haven't necessarily caught up with the technology. The technology itself is a bit of a black box for them. They trying to secure Kubernetes workloads using traditional security, which was at a workload or a server or VM level, right? But in Kubernetes, you need to go one level beyond that, you need to go to the point of the container to secure workload communication, right? So as Kubernetes is gaining adoption, we are seeing security folks getting increasingly involved to understand the technology so that they can secure the technology. Yeah.
Service meshes enforcements provided, couldn't service meshes like this you enforce separation between pods by vector cyclers or even using UTF?
Yeah, correct. It's still good at a service to service level. Deploying a service mesh is a huge undertaking, right? So every Kubernetes cluster has to have a CNI that provides port-to-port networking, and Calico is not a CNI, and you can implement security by using the CNI without the overhead of injecting like sidecar containers and operational overhead that comes to maintain the service mesh. There are legitimate reasons for a service mesh, such as mutual TLS authentication, encryption, this level of microsegmentation provided by the CNI can coexist with the service mesh as well. So while the service mesh may operate at a layer 7 application level, the CNI can operate at a layer 4 level, right, at a network level. So the solutions are not mutually exclusive, so to speak. Implementing with the CNI is obviously a lesser overhead, but even in cases where you have a service mesh, the two solutions can coexist. They offer different benefits. Yeah. All right. So, most of you, I believe, were familiar with Calico. And Calico is a CNI. So every Kubernetes cluster has to have a container network interface, right? Calico was one of the early CNIs. And who can tell me the job of the container network interface in Kubernetes? Anyone?
It provides all networking.
Yes. It provides what network to be more specific, right? If you look at a Kubernetes cluster, it's made of hosts, right? And these hosts could be VMs or servers, right? So a cluster could be 10 hosts, it could be 500 hosts, right? And your containers are running in these hosts, and you as an operator, you don't have any control over where these containers would be running, right? And these hosts exist in a typical network. It could even exist in multiple networks. We've seen Kubernetes clusters, a single cluster spanning on-prem data centers as well as the cloud. A single cluster for which the hosts are on-prem as well as the cloud, right? So think about that. And inside a cluster, the entire infrastructure, the hosts and the network has to be abstracted for the containers. Think of a scenario where you have a single cluster spanning on-prem and in the cloud, and you need to provide a layer of abstraction from infrastructure standpoint, right? And the CNI plugin is responsible to ensure that pods, regardless of where they are scheduled, are able to seamlessly talk to each other, right? It's a core function of the Kubernetes ecosystem, and it's a very elegant solution. It works seamlessly. You spin up a cluster out of the box. It pretty much works seamlessly, but under the hood, there are several networking technologies that are leveraged to ensure that pods can seamlessly talk to other pods in the cluster. Okay. So Calico is one such CNI. Now, the challenge with Kubernetes is, as you start migrating your workloads, at some point you're going to run into this issue, right? Security is going to get involved, and for the security personas in your organizations, they require a few things, right? If you look at these Kubernetes workloads, these workloads are talking to services inside the cluster. They may be talking to services out there in the internet. They may be talking to services in your wider, enterprise infrastructure. If I go to a customer, there's a customer that typically hasn't implemented some kind of observability solution, but I ask the customer, hey, Mr. Customer, can you tell me all the services pod A communicated with in the last 24 hours? And in most cases, the answer to that is, I don't know the services this pod communicated with in the past 24 hours. Right? even as we build your Kubernetes clusters and operationalize these clusters and productionize these clusters, this is a good question to ask yourself. Tomorrow, if I was compromised, do I have the level of visibility? Have I implemented the right controls to ensure that my blast radius number one is limited? And also ensure that I have the right level of logging to do some kind of threat response and policy analysis, right? So we're seeing that for many of the mid-sized and small scale customers, this becomes a bit of an afterthought. In the large organizations, they have a platform engineering approach. These questions are addressed up front and it's baked into their platforms before they roll this into production, right? But the mid to small size organizations, they understand the power and benefit of Kubernetes. They go about rolling these clusters in production and later realize that they don't have the kind of visibility and security that they previously had in their traditional environments, right? So this is the challenge, okay? So just to talk a bit about networking and some of the technologies involved here, when you look at a CNI such as Calico, it is tightly integrated with Kubernetes. It is what we call a Kubernetes native solution, right? There are certain requirements a product has to adhere to be considered Kubernetes native. So with the tight integration, Calico has access to what we call the Kubernetes data store. Can anyone tell me what the Kubernetes data store is used for? Yes. The data source at SC, so it's used to store the state of the cluster, right? In Kubernetes, we have a collection of what we call resources, and the data store is used to store the state of the cluster. Now, Calico has access to this data store, and what that means is it has access to all the workloads running in your cluster, and it knows about all the workloads running in your cluster. And the CNI, as I said before, is responsible to provide that networking for port-to-port verification, and Calico leverages several technologies, such as IP/IPv6 and BGP and networking technologies to ensure that pods can seamlessly talk to other pods in the cluster. Now, in addition to networking technologies, Calico also would leverage one or more data planes to enforce security, right? And you may have heard of some of these data planes, eBPF, IP tables, window versions, etc. And these data planes are used to ensure that from a networking standpoint, Kubernetes operators are able to implement network policies to ensure that pods can only talk to pods or services that they are authorized to. Okay? Without these policies, the networking Kubernetes is open, and pods can discover and talk to every other pod in the cluster. Okay. Right. Okay, so from a networking standpoint in Kubernetes, I mean, this is what pod-to-pod communication looks like, right? A given pod can talk to every other pod in the cluster. Now, where you want to get to is something like this, right? So in the clusters that we've seen, very large scale clusters, especially some of the big banks, they may have dozens of development teams deploying workloads and applications to Kubernetes, right? In certain managed service providers, they have multiple customers deploying workloads to the same Kubernetes cluster. So although Kubernetes natively doesn't have a concept of a tenant, from an organization standpoint, from a security standpoint, you may have a concept of a tenant, a business unit, right? Whereby you may want to isolate the workloads of a certain tenant or certain business unit. So let me isolate, it's pretty simple, right? You look at this diagram, tenant 1 should not be able to talk to tenant 2. If you're a managed service provider and you have 2 customers, obviously you don't want customer 1 to even be able to discover workloads or applications belonging to customer 2, right? So it's a very simple concept, and it's a very, very legitimate, requirement from a security standpoint, right? Now, over here, I have a very simple diagram, right? A few workloads, but think of a Kubernetes cluster with dozens of tenants, hundreds of namespaces, thousands of workloads. In such an environment, how do you implement microsegmentation? This is challenging at the same time an exciting opportunity because of the platform-centric approach of Kubernetes. In a traditional environment, where we had the VMs, where we had data center networks, or even in the cloud, implementing microsegmentation was very challenging because, like I said, the infrastructure and the workloads were decoupled. But in Kubernetes, we have tight integration between an infrastructure component such as Calico and Kubernetes that provides us the visibility into all the workloads running in the cluster, and a solution like Calico thereby can implement security based on workload identity, right? The identity of the workload. Okay. All right. So hopefully you understand the problem that we're trying to address, right? That's the first thing, right? Any questions, regarding this?
So is the benefit of this approach over a multi-cluster approach mostly from a management perspective, or am I missing something?
Yeah, so we've had instances where customers for security purposes have to deploy multiple clusters, right? But as we build Kubernetes, we are seeing customers consolidate these clusters. Obviously, you want to benefit from some of the scaling capabilities that Kubernetes offers, right? But also, if you consider a single cluster scenario, the cluster does not only run your workloads. In this cluster, you could have open source components, you could have workloads from third-party companies, right? You have Kubernetes components, and then you have your actual applications, right? So instead of having to duplicate all of that again and again as you build, multiple clusters, you could obviously benefit from consolidation. But even if you have those individual clusters, that doesn't negate the requirement to ensure that your workloads remain isolated. Right. Yes. All right. Just give me 1 minute here. All right. Okay. So let's kind of take this home with a demo. All right. This is an example Kubernetes cluster connected to Calico Cloud. Just Google Calico Cloud.io. You can sign up and connect your clusters. Once you connect a cluster to Calico Cloud, the first thing that you're going to get is visibility into workload activity, right? So typically in Kubernetes, you wouldn't have this level of visibility. I have what we call a service graph, and security first starts with visibility, right? At the network level, you want to understand everything that's going on in cluster. Now take this graph and multiply this by 10, 20, 30, or 50 times. We've seen clusters that big in actual production environments, right? So there's a lot going on, even in a small cluster, such as this. And many customers we speak to, without visibility such as this, wouldn't know the communication that takes place in their Kubernetes clusters, right? So if you don't know what's happening, you're not able to secure it, right? So security first starts with understanding what's happening in your clusters and getting the required level of observability so that you can implement the appropriate adequate level of security. Okay. Now the graph that I'm showing here is an abstracted graph. This is a graph at a namespace level in Kubernetes, right? Now, if I go into an individual namespace, I can kind of zoom in and let's take a namespace here, such as the hipster shop. I could double click. Let me take another one. And as I double click inside a namespace, this is all the activity, inside one namespace, okay? So containerization is great, but with containerization, we now have an explosion of workloads, communicating with each other, and we need an effective mechanism to secure this communication, right, at network level, right? If you go and show this to your security teams, they're going to start panicking because previously they had the visibility in traditional networks, right? They had the firewalls, they had the login solution that provided them the visibility. Now, when you start containerizing your workload and moving into Kubernetes, suddenly they lose this visibility. And if they're not aware of what's taking place under the hood, they'll not be able to protect it, right? So in some customers, in many kind of mid and small size customers, what you're seeing is that the traditional security personas in the organization have not kept up with the technology. They don't fully understand Kubernetes. They don't understand what's happening in this cluster. So for the most part, the DevOps folks, the platform folks have been able to get away without implementing the security control. But like I said, as your organization increasingly transitions the majority of workloads to Kubernetes, you're gonna face this problem eventually, right? So as you architect your clusters, it's always better to make sure that you bake security into the cluster and ensure that you have the right level of observability to be able to operationalize these clusters and be prepared for what we call day two, operations, right? Because it's easy to get started with Kubernetes, where you run into problems is during your day two operations. Okay. All right, so we first of all, start off with visibility, right? And as you look at this graph, and you're seeing some red lines, you're seeing some green lines, and a green line is basically a connection that was allowed, a pod-to-pod connection, and as you can see, these are the logs that indicate that the connection was allowed. And whenever you see a red line, that is because there's a certain security policy that was implemented to prevent that connection. Now, let me zoom in a bit here. And if I look at the service graph, I have a policy here in red. It's called tenant to restrict, whereby I'm restricting certain communication from my tenant to namespace. And this policy has denied this communication that I've highlighted here. Okay. Now, I don't have time to go to the details of security policy and implementation, but I want to give you a high-level picture of what this looks like, inside Calico. Okay. So in Calico, we have, what we call this hierarchical approach to security, and what you see here are what we call certain tiers. You have security platform, application, etc. An interesting phenomenon with Kubernetes is, previously teams were siloed, right? We had the infrastructure team, the security team, the application team, With the DevOps phenomena, we had a tight integration between application developers and operation folks, right? But with Kubernetes, to be able to operationalize a Kubernetes cluster at scale with the right level of governance, so think of yourself as being one of those big banks, right? We want to operationalize Kubernetes at scale. To be able to effectively do that, security has to be considered a shared responsibility. You need to bring the security folks, the application developers, you need to bring the platform folks, the DevOps folks, all to the same table. And that's what we've seen some of the large customers do, right? I'm talking about the big banks, the card companies, etc. Security is treated as a shared responsibility. And what I'm trying to demonstrate here is how that works. So security persona is typically involved in defining those high-level controls. You know what? I want to block all traffic to malicious IPs based on directory. I want to make sure that I isolate my tenants, right? These are what we call the high-level guardrails that security is interested in. And the platform, for example, I think most of you might fall into that category. You would want to protect your platform components. In Kubernetes, you have components such as DNS, you may have certain logging solutions, certain metrics gathering solutions. Those are your components. You own those components and you may want to protect those, right? So your policy is sitting in the platform here. And then you tell your application teams, hey, you know what, this cluster, instead of being an open cluster, is a default denied cluster, as in, just because you deploy a workload doesn't mean those workloads will be able to communicate with any other workload in the cluster. You need to make sure that you deploy the relevant policy that enables those workloads to communicate with the services that it should be and is supposed to be communicating with, right? And we've seen organizations, so it's not just a technology shift, it's also a cultural shift, right? Teams are not used to kind of operating this way. And yes, one person could manage all of this, but in the world of DevSecOps that we are kind of moving to, you know, organizations have to go through this kind of cultural shift where they treat security not as a silo, but as a shared responsibility, right? And that's what the Calico security model enables, you know, customers to do, okay? So we see customers in both sides of the spectrum, right? On the far side, we see customers treating security as a silo, and we're also seeing customers where security, they've been able to, so to speak, democratize security, right? And as customers increase their Kubernetes adoption, we see more and more customers embracing, you know, DevSecOps, you know, principles, right? So it's always better to be prepared and better to kind of get ready, because at some point you're going to come across this issue, especially if you're operating Kubernetes cluster. All right, any questions?
Okay, so you're talking about the tenant-based model. So how are you defining the tenants? Is it just a label?
Yeah, so it could be the label, you could specify the namespaces, and or it could be even based on your service accounts attached to certain workloads. Yeah.
The pods,
What's that?
the pods, the pods.
Yeah, it could be based on pod labels as well. So labels in your deployments, you know, labels in your stateful sets. It could be based on those as well.
But there's no like higher level. I mean, I'm not complaining about it. I'm just curious, like, yeah, anybody, if you have permissions, you can put a link. What would a tenant be?
Correct. So the way customers get away with that is using some kind of admission control solution, right, to ensure that certain labels can only be injected. You would need some kind of governance either through your GitOps, right? Admission control when you're deploying Kubernetes. So this has to be coupled with some kind of governance structure, right, to make sure that somebody doesn't mistakenly apply a label, you know, of another tenant. Yeah.
It's not really about tenancy. I was just wondering, does Calico, would you say it replaces Kube proxy, or would you still use Kube proxy in certain places?
Yeah, so Calico can replace Kube proxy if you're using the EVPF data planes. You can replace Kube proxy with Calico. The reason you may want to replace Kube proxy is we have a large number of services, right? So in such instances, in hyperscale clusters, you may want to replace Kube proxy with a BPF solution. But in most cases, you know, Calico works with Kube proxy, right? Calico is involved in configuring the rules for security policy, whereas Kube proxy is involved in configuring the rules for, you know, services, right? So it works in conjunction. But we have customers who replace Kube proxy with Calico as well. Yeah. Question. Yes.
So going back to your earlier question, but answering answering the question of what URLs you are connected to in the past 24 hours.
Yeah.
How do you use Calico to do that?
Yes. So Calico, in the Calico flow logs, there are about 42 data points that are gathered. So if you have a workload communicating to an external domain, it's going to be populated in the flow logs, right? Calico also records all DNS requests and responses in the cluster. So any DNS request or response, either QDNS or a forward DNS server, is also captured by Calico, right? So, for example, if you have a pod that's trying to use a domain generation algorithm, right? Trying to manage domains, all of that is captured by Calico as well. So, right. So the logs. Customers may come up with their own solution for log storage, right? They could forward these logs to a centralized log archival solution, right? That So Calico is a commercial product that where, customers, we give it's a SaaS offering, so logs are sold in the SaaS. But else, customers will have to come up with a way of storing the logs, yeah. Yeah.
I would like to have your thought on like how all these networking solutions could converge. That's why, because in one of the slides, you said that like the external firewalls could not map an IP to a workload identity. That's like the old words, say like 14A Palo Alto solutions. So it's a black box for, right? So we're talking about network admins. They're still in the organization. So it's siloed maybe, but they're still then their job to make sure everything is filtered, monitored. And on the other side, you got solutions like Service Mesh or Ambient Mesh, the EPF that would maybe sort of try to have a visibility on layer 3, 4, and also these two is taking care of layer 7. So would you say that at some point that it would be like just would everybody need help with at some point where companies like Cisco would provide something that would have visibility through the cluster networking and try to do the work they used to do in the traditional infrastructure, or maybe like companies like Calico would try to fill that gap and help the mutual integration, or they will just all work on their corner. So
It's a very, very good question. This is something we deal with customers all the time, right? We have folks on the networking team, they come and tell us, you know what, there's this Kubernetes thing that's going on, we have no visibility. Whenever there's an issue, we get called to it, like a particular issue, you know what, my service call is taking too long, right? They call the networking team, they're trying to figure out, okay, where is this call originating from? Like Kubernetes, the service could be backed by 10 pods distributed across 10 nodes, right? So visibility is a huge challenge. And at some point, this will have to get converged. You can't have teams working in silos. And that's the whole kind of philosophy around Calico is the shared responsibility model, right? That's what we advocate. And I think companies such as kind of Cisco will have to kind of bring that visibility in, right, to and kind of empower network admins, right? So Calico open source, you might be aware, we support a Cisco back data plane as well, BTP, right? Some of the other data planes that Calico supports, but at some point this will have to converge. And with Kubernetes, what we're seeing is it's becoming increasingly difficult for organizations to operate with their traditional siloed approach, right? Because you have an environment where workloads are tightly coupled with the infrastructure, right? In such cases, it's important that the teams have the right level of visibility. We have some of the banks, even here, that we work with that want to provide their application developers this type of visibility. Because they're like, you know what, if the application is having some issue, maybe the developers can log into the UI to see if there is a network issue, right? And empower the developers as well, right? So more and more with especially things like DevSecOps, we're seeing a lot of these things kind of converge where security is treated as a shared responsibility, right? And that would also involve empowering, networking teams, because the network portion of security was traditionally what they owned, right? And we're seeing that kind of getting transition towards kind of platform teams and security teams, right? So organizations, it's a phase, right? And they really have to kind of figure out how they get over this cultural shift that's required. But it's a very nice question because this is something we deal with kind of day in and day out,
Yeah, exactly. I also think for now in the cloud native resources, sometimes like these firewalls, they know that some resources don't have a parent line.
Yeah.
Exactly. Where there's like a tag.
Yeah.
Like we have like a dynamic group.
Yeah.
I don't care about the IP, but I will put them in that firewall rule.
Exactly.
Tag, right. But I think they would need more than that to actually match what's what exists in Kubernetes. So would you think it would come by acquiring a company that's specialized in Kubernetes?
Right, yep, yeah, probably, I guess, I mean, the problem that you're describing is something every organization faces, especially if you have your traditional infrastructure and Kubernetes environments. The problem that you're facing, and Kubernetes has no native way of addressing this issue. Calico, the enterprise version of the product, had what we call egress gateways, which is very similar to a NAT gateway to address this issue. So what typically happens is every development team gets their own egress gateway. That way they know their exact egress IP, and they use that to create firewall rules to other places in the environment, right? But this problem that you're explaining is something, it's a pain that everyone has to eventually kind of go through. So yeah, like I said, at some point, right, to address these challenges, these teams will have to converge. Yeah. Yes.
By implementing this execution, right, aren't we increasing complexity to maintain the policy type of when trying to implement 100 policies at the VLAN level?
Yeah.
We are doing something by
You know,
like the layers or like
yeah, that's a very good question, right? So with kind of platform engineering approach, you somewhat have to engineer your teams as well. And the customers who have done this well, it just works like a well-oiled machine, because previously you had this one team implementing firewall rules or kind of security groups and the rules, right? But with the shared model, as we distribute policy authority to multiple teams, what happens is for a single application team, it's just about the application. All they're concerned about is, this is my application, this is what it's supposed to talk to, right? And we have customers with thousands of policies, we all have dozens of application teams. And it works so seamlessly because each team is just concerned about their policy. And in Kubernetes, everything is declarative, right? So you say, hey, my application A should be able to talk to application B, that's it, right? You define that, and Calico takes care of everything else, right? Regardless of how your application scales or where it is scheduled, the policy will follow the application, right? And that's the beauty of Kubernetes because of its kind of API-centric, approach. So something we were not able to do in traditional infrastructure, right? We're able to do in Kubernetes, and it's kind of much easier with Kubernetes. But I think, are we out of time?
Yes, sorry about that.
No worries.
You have it. Maybe you can have some questions later.
Okay.
Sure.
You want to run the quiz?
Okay.
All right, thanks all. Thank you for the questions. No worries. I know. Yes. Okay. No worries. Fine, that's okay. That's no problem. No worries.
Okay, thank you so much for joining. We do have a small quiz. I won't take much time of yours. And with the leaderboard of the quiz, we will have some exciting giveaways as well. We are not disclosing it Okay, so the QR code would be on your screens, and I'll wait for a moment for all of you to join, and then we'll start. So basically, we do have 10 questions. Each of them would have 4 different options, and yeah, whoever does the fastest would be the winner. So we might have 5 to 6 prizes. So yeah, and this would be nearly related to whatever we discussed in both of these sessions. So yeah, it's kind of a knowledge check for all of you as well. You can scan the code or you can visit this URL as well. And I'll start in 1 or 2 minutes maximum. Okay, I'm starting it right now. Sorry? I'll start it. So the question will pop up afterwards. Is it?
No one can join?
Yeah, of course, it will. I'll do it on from my.
He will start.
Of course.
Okay, started. Start the Nice.
Okay, it would be live now. Okay, so I'm releasing the first question. Just a second. No, because I got 10 participants with the correct answer. Just 1 second, let me check. They can't see the questions. Okay, I think there is some misconfiguration. I would really request you to refer this question on the screen and read it. Or either I can read as well. So yeah, let's go with the next one. So Okay, the third one. What is not Linux technology fundamental to containers? The options are SLinux, C groups, namespaces, advanced packaging tool. The fourth question is, to satisfy the Kubernetes networking model, pods must be able to communicate with other pods in the same host. Pods must be able to communicate with other pods in the same VLAN. Pods must be able to communicate with other pods in the clusters. Pods must be able to communicate with all pods in clusters with NAT. Okay, the fifth one. In Kubernetes, which resource type is used to store sensitive information like password, API keys, and tokens? The options are config map, daemon sets, deployments, and secrets. This one is easy. The sixth one, what is the policy enforcement data planes supported by Calico? eBPF, Open vSwitch, NF tables, IPVS. Okay. The seventh one, what's the recommended way to access secrets stored in Kubernetes within a pod? Environmental variables, HTTP GET request, direct file access in the file system, and none of the above. Okay, 21 participants got it right. The eighth one, in Akeyless secrets, how is the secret typically stored or managed in a Kubernetes cluster? Distributed across multiple nodes, centralized storage as a secret vault, fragmented and spread across various locations, stored in plain text within the secrets. Okay, the ninth one. What is the purpose of universal identity authentication method? Simplify encryption techniques, enhance access control, speed up data retrieval, and reduce network latency. Okay, the last one. In Akeyless security infrastructure, what is the primary function of Akeyless gateway? To manage Kubernetes clusters, to store encrypted secrets, to perform load balancing within the network, to provide a secure entry point for accessing keyless services. Okay, we barely have 5 seconds left. Okay. Of course, that was from the presentation. Okay, let me open the leaderboard. Okay, congratulations to the top 6 people. We have 2 different giveaways. So from the leaderboard, who is 1, 3, and 5 would get exclusive 6-month Core Cloud subscription. Core Cloud, I think everyone must be aware. And for the serial number 2, 4, and 6, we have 3 physical ebooks from Pact. So yeah, we would be giving away. So I would like to call all the 6 winners on the stage. So I might not be able to pronounce your name right, but yeah. For the ones who didn't win, we do have some giveaways there as well. So thank you for joining. And our next event is on 25th January. So I'll see you again. Thank you very much.